and Animal Adaptations, written by Susan Virgilio. Focus question: how and why do some animals adapt? A penguin surprise, survival strategies, a slow process, odd diets, the blood runs cold, masters of disguise, life finds a way, glossary. A penguin surprise. When you think of penguins, what image comes to mind? You'll probably imagine black and white birds sliding down snowy slopes and diving into icy waters, not sunning themselves in tropical islands near the equator. You might be surprised to learn that one kind of penguin inhabits just such a place. The Galapagos penguin lives on warm islands in the eastern Pacific Ocean. How does a species originally from Antarctica survive in such a climate? It changes over time, gradually developing physical and behavioral adaptations that suit the conditions. The Galapagos penguin is not the only species to do this. Most animal species exist today because of how they changed and adapted to their surroundings. Survival strategies. The ability to adapt is key to any living thing's survival. If it cannot thrive where it lives, it must change, go somewhere, or die. There are two types of adaptations. One kind has to do with an animal's behavior or how it acts. For instance, animals that migrate from one place to another in search of better food and living conditions demonstrate a behavioral adaptation. Migration usually happens when seasons change. Monarch butterflies, for example, fly south to Mexico and other warm places when fall arrived in the northern summer homes. In the spring, they head north as temperatures rise. Hibernation is another kind of behavioral adaptation that occurs when seasons change. Instead of moving to a new place, some animals stay put and go into a state somewhat like sleep. True hibernators include frogs, ground squirrels, and bats. Many animals thought to hibernate, such as bears and skunks, actually enter a lighter state of sleep called torpor. Both groups of animals enter these states during cold winter months when food is scarce because they use less energy and need less food. When outside conditions improve in the spring, they become active again. By contrast, structural adaptations are changes in body structure that make it easier for animals to live in the environment. These changes happen slowly over many generations. Chameleons, for example, develop skin that can change color, which helps them blend in with their surrounding and makes it hard for predators or prey to see them. Foxes have structural adaptations that help them use camouflage too. The Arctic fox has a white coat, which makes it hard to see in the snow, while the desert fox has a tan coat, which blends in with the desert sand. Both foxes have other structural adaptations as well. The Arctic fox has much smaller ears than its cousin because foxes lose body heat through their ears. The Arctic fox lives in a cold environment, so it needs to hold in body heat. The desert fox, on the other hand, lives in a hot environment and needs to stay cool, so it has very large ears that help it shed heat. Oddly adaptable. Some adaptations are odder than others. Take walking sharks, found in waters near Australia and Indonesia. These small sharks have very strong front fins. At times, they use their muscular fins not to swim but rather to crawl across the ocean floor. Giraffes have a few odd adaptations of their own. Dig deep into a giraffe's coat and you'll end up holding your nose. That's because giraffe fur works as a chemical defense. It is full of antibiotics and other smelly chemicals that keep parasites away. Giraffes also need very little sleep. Most giraffes get by on just 2 hours of shut-eye a day, and nearly all of that is while standing. Both behaviors help protect them from predators. A walking shark takes a seabed stroll at night, and even when lying down, giraffes usually keep their necks held high. A slow process. Animal species don't think about ways to change. Adaptation happens naturally over time. Early bears that entered a state of torpor survived cold winters. The bears that didn't died. As a result, only the first group of bears was around to reproduce. Something similar happened with foxes. Arctic foxes with small ears survived, while those with large ears did not. The survivors mated, and in time, all the foxes in that environment had small ears because the feature was passed down. Animal species evolved through a combination of behavioral and structural adaptations. The Galapagos penguin is a good example. Galapagos penguins found their way to the tropics by way of the Humboldt Current. This current carries cold water north from Antarctica and is rich in squid and fish like sardines. The penguins are right home in the cold water. They must come on land to nest, however, and land in the tropic is much warmer than water. Galapagos penguins have ways to cope with the heat. They pant to keep cool, and they stretch out their flippers to shade their feet and keep them from getting sunburned. The penguins build their nests in burrows between rocks, hidden from the sun's rays. While other penguins molt once a year, Galapagos penguins molt twice. Shedding their feathers helps them stay cool. These penguin behaviors and features developed over time. Penguins that lacked them died off. Our diets. Diet is a behavioral adaptation. Some animal species have developed eating habits that help them survive. Kangaroo rats, for example, live in deserts with little water or rainfall, yet somehow survive without ever drinking water. They get the moisture they need from eating grass seeds and mesquite beans. A parrot known as the scarlet macaw eats seeds too, except these seeds contain a deadly poison. What may keep the macaw safe is its habit of also growing on rocks that contain clay. The clay absorbs the poison, which allows the birds to digest the seeds safely. Then again, new studies suggest the birds may be eating the clay in order to increase the salt in their diet. Either way, the instinctive behavior is a dietary adaptation that helps the bird survive. Strange ocean creatures known as tube worms have their own way of dealing with poison. Tube worms live in total darkness at the bottom of the Pacific Ocean and cluster near hot vents that pump out dangerous gases from deep inside Earth. The gases could kill most life forms, but tube worms survive and even thrive thanks to their odd body structure. They lack body parts we would expect to see in animals, such as eyes and a stomach. They are basically bags of bacteria. The bacteria inside the tube worms use the gases as an energy source. The blood runs cold. Sub-freezing temperatures can kill an animal. Animals' body cells are mostly made of water. When cells freeze, the water turns to ice and expands. The cells burst, which causes death. Animals have developed different ways to keep this from happening. When temperatures drop, some species migrate to warmer places, while others sleep in warm dens. Still others stay alive by supercooling their body fluids. Many insects produce chemicals that act as a kind of anti-freeze. The chemicals keep ice crystals from growing, so body cells get super cool but never freeze. This adaptation helps cockroaches and caterpillars survive freezing temperatures for days. Alaska's red flatberg beetle can supercool its body fluids to minus 50 degrees Celsius. Wood frogs can survive for weeks at a time when temperatures drops as low as minus 14 degrees Celsius. Although ice does form within frogs' bodies, it forms between cells rather than inside them. That way, cells are not at risk of bursting. Other animals adapt by simply getting rid of the water in the body through a process called dehydration. Tiny insects known as Antarctic midges dry up, appear frozen, and seem to be dead. When they come in contact with water, however, they spring back to life. Only one mammal can supercool its body, the Arctic ground squirrel. The squirrel's body temperature can drop as low as minus 3 degrees Celsius. Just how it does this is a mystery. It doesn't make its own anti-freeze, nor does it get rid of fluids, yet somehow it has adapted to survive very low temperatures. Masters of disguise. Another structural adaptation is the ability to camouflage. Some animals are true masters of disguise, such as the leaf mantis. Parts of its body are the exact shape and color of dead leaves, a remarkable adaptation that makes it easy for this insect to hide and hunt on the forest floor without being seen. Like the mantis, the cuttlefish can masquerade as part of the landscape. It looks like a small squid. Its skin changes color and texture to match its surroundings almost perfectly. The cuttlefish has three layers and fleshy growths called papillae, which it uses to make itself look like palmy coral or stone. This makes it practically invisible to prey and also keeps this effective hunter from being hunted itself. Adaptations are only helpful if they work, though. Changes to an animal's habitat can turn an effective adaptation into a fatal flaw. This is what happened to an insect known as the peppered moth. Most early pepper moths had white wings with dark spots. The moths easily blended in with lichen-covered tree bark. Predators such as birds couldn't see the moths. Some peppered moths, however, were only dark. Those moths were easy targets for birds, and as a result, there were many more white moths than dark ones. During the Industrial Revolution in the 1800s, pollution from factory smokestacks killed the lichen and turned the tree bark black. Now the dark peppered moths could blend in and hide. The white moths stood out against the dark bark. Birds could easily see them now. The number of white moths dropped while the number of dark moths rose. When pollution controls took effect in the 1900s, the tree bark turned lighter again, and the moth populations shifted once more. Dark moths became rare once again. Even though the color variation may have been a fatal flaw for some individual moths, it allowed the species as a whole to survive in a changing environment. Life finds a way. Adaptation is especially important in environments that are going through change. For most living things today, that change is climate change. Animals like the Galapagos penguin must once again adapt to conditions around them. As ocean waters warm and food supplies grow scarce, the penguins must change how, what, or where they eat. The same holds true for animals around the planet. Most will survive as long as they continue to adapt and respond to the changing environment, if they have time to adapt. A race against time. Many species are being pushed to adapt to climate change, but adaptation takes time. In a race against the clock, the outlook is better for some than others. Tiny owls come in different shades. With milder winters in recent decades, researchers in Finland have seen an increase in darker owls. Less snow means these owls blend in better and are more likely to survive and reproduce. Polar bears may have evolved from the brown bear, ancestors as far back as 600,000 years ago. It took the species time to adapt to its conditions. Black skin, white fur, and fur-covered feet adaptations that make the bears well suited for Arctic survival. Now, loss of the sea's ice habitat due to global warming poses a dire threat to polar bears. They were listed as a threatened species under the Endangered Species Act in May 2008. American pikas are cute but tough. Although they live high on mountains, they have adapted to a cold climate. When exposed to warm temperatures, pikas can overheat and die. But since pikas live so high already, there's nowhere for them to go. Trapped at the top, they could be one of the first species to be extinct due to climate change. Here's the glossary of some new words that you will learn from this book. So most of this I've already known, just some of them, such as hibernation means the state of deep sleep that some animals go into during water. Or masquerade means to pretend or appear to be something or someone else. Torpor means a state of low activity, a deep sleep, but not as deep as hibernation. Connections. Writing. Choose two animal adaptations from the book to compare and contrast using a Venn diagram. Write a paragraph describing the similarities and differences. Share your paragraph with a partner. Science. Research to learn more about one of the animals in the book. Design a poster that includes the animal's behavioral and structure adaptations to share with the class.
Good job.
Now let's do the quiz. How is the Galapagos penguin different from other penguins? It is not originally from Antarctica. It changed to suit the conditions of Antarctica. It is adapted to the conditions of a tropical island. It is not a black and white bird like other penguins. What was the author's purpose for writing a section survival strategies? To suggest that animals need to develop better strategies for survival, to emphasize the adaptations that are necessary for living things to survive. I think A. Which of the following is an example of a behavioral adaptation? Tan fur, big ears, color-changing skin, migration. Which of the following conditions cause the difference in size between Arctic fox ears and desert fox ears? Color of surroundings, temperature of environment, because desert fox ears live in warmer temperature. Adaptation leads to a species evolving because one adaptation keeps tube worms alive when they live near hot vents that pump out poison gases. Bass bears, wood frogs, and red flatbark beetles all have adaptations that help them survive. I forget this detail, to be honest. Bears, so tropical conditions. I know. The leaf muttons and the cuttlefish both have adaptations that I have made them blending with dead leaves, allow them to look like the surroundings. What caused the number of light or dark peppered moths to change? What is the main idea of the section? Life finds a way. A force to adapt. Depends. Okay, depends. But I think.
Close.
Click on the items with the red X.
It's not to suggest that animals need to develop better strategies for survival. Then, I think B. It's not tropical conditions, then cold temperatures, right? Or hot. It's not birds became rare, the tree bark colors changed. Where the main idea of there is not like A. It's not like C, so it's A, right?
You passed. Now
Click on the items with.
Oh my god, it's not even hot temperatures. Cold, okay?
You're amazing. A perfect score.
Bye.